Okay, today we're going over the muscles of the lower leg and foot. But first, let's have a quick review of the bony anatomy. So we have below the knee, we have the tibia, we have the fibula, all right, which comes down and it intersects down at the ankle into the talus. And then your heel of your foot is going to be the calcaneus. All right, then we go into the metatarsals here. The tarsals here. You got your tarsals, cuboid, lateral cuneiform, intermediate cuneiform in between, from the lateral towards the outside of the body. Then you have the medial cuneiform towards the inside of the body. Then you have the navicular, which I think of a captain's ship. It looks like a boat. Okay. Then we go from the tarsals intersecting into the metatarsals. So big toe being first, second, third, fourth, fifth at the pinky toe. Then of course we have our phalanx or phalanges, 1 through 5. And then the big toe is called the hallux. Okay. So remember, we have fascia, superficial fascia that covers over top. And again, this fascia is interwoven with our nervous system. So any sort of trauma or tension to the leg, it's going to squeeze down and kind of vacuum seal all of these muscles together. So our job is to communicate with the nervous system to relax the fascia, relax the skeletal muscles, to allow us to palpate and maneuver the muscles independently the best we can. So the best way to understand this, like I said, is going through the muscle actions. So we're going to go down here to the lower limb. So starting with knee flexion. So this upper thigh pelvis is stable. And we're working at the knee. So we have the gastrocnemius, right? The two chicken tenders, two chicken breasts here. It's coming up on the posterior side of the knee and attaching to the femur, posterior side of the femur. Then it's coming down and creating the Achilles tendon. Again, this tendon is a thick fibrous band, so it's not going to be manipulated very easily. But the more contractile force is in the gastrocnemius, that is going to pull up on that Achilles tendon, causing more tension. All right. So as well as this gastroc at the lower limb, we also have our hamstrings pulling and assisting this movement. So this muscle is doing the majority of the movement. Then we have these assisting muscles pulling up on the tibia to assist the traction of this patella, right? So it's keeping this joint stable as the leg goes up, which is super important to have stability in the knee. And having tension equally on both sides is going to keep that lower leg straight. So when you walk, your foot is going in line with the direction of your walking. All right. Now we're looking at knee extension. So as you can see, we're talking about the muscles of the lower limb, but in knee extension, these muscles are not engaging as your prime mover. They're going to stabilize the ankle and foot as you land. But your quads are going to do the pulling action to lower that limb down. So these muscles are going to be contracted and stable as you put your foot down in that kind of swing phase. All right. And again, with the upper muscles, with the medial and lateral rotation of the knee and the tibia. All right, so now we're going down to the muscles that solely work with the lower leg. Okay, so these muscles don't cross the knee joint, so they're only going to affect the joints that they cross, right? So from the tibia, coming down, crossing the ankle into the foot. So dorsiflexion, bringing, if on the top of your foot you had a shark fin, it's going to bring the shark fin to the surface. So this is the dorsal side of the foot, the back side of the foot. So we have tibialis anterior, which is going to come from the anterior side of the tibia, and then it's going to run under the medial side of the foot. So these muscles are really going to come down and wrap around the bones of the foot to help support that surface here. As you're walking, as you're jumping or stepping and landing, you need support of this arch and of these bones in the middle of the foot. So these muscles are coming across, and they're going to actually lift the foot and be able to actually turn the foot in different directions for the uneven ground that you are stepping on. And especially when you're walking barefoot, you're going to have this surface open. You don't have the shoe actually kind of covering this flat surface. So these muscles are going to assist you in your ankle not rolling too far in and out. So then we have extensor digitorum longus. So extensor, working in extension of the foot. Digitorum, referring to the digits of the toes. And then longus, because it is a long muscle. You see how far it goes from all the way up at the top of the tibia, all the way down to the tip of your toes. Then we have extensor hallucis longus. So again, the action is extension, hallucis referring to the big toe, and longus because it is a long muscle. So this is lifting your foot up, preparing you to take a step forward. Then we have plantar flexion. So you're walking outside in the garden and you're stepping on a plant. So you're pointing your toes down or you're pressing on the gas. So as you can see, the pivot point is the talus here. The talus in connection with the tibia and fibula. So just like a seesaw, if one person pushes off and pulls up, it's going to bring the other side down. If this side comes up, this other side goes down. So your foot is like a seesaw, and this is the fulcrum here. But it's more like a wheelbarrow because the seesaw, the fulcrum will be right in the middle of the foot. This is towards the end of the foot, so it's more like a wheelbarrow. Okay, so if this is pulling up on the calcaneus to pivot, then let's look at the muscles that are involved in that action. So the Achilles tendon attached to the gastrocnemius, the large calf muscle, is pulling up. So you're stepping up on a stair or pointing your toes to do ballet. So this muscle is going to be engaged. This is why when women wear high heels and they put their foot in this position, this calf is very prominent, and it the body looks better because this muscle is more prominent and it gives it more shape. So you have your soleus muscle right underneath the gastrocnemius. All right. And then underneath there, you have the flexor digitorum longus. So it's coming from the posterior side of the tibia, coming around the medial side. So you see how it wraps and kind of supports this foot. And then it spreads out and it spreads to each toe. So flexor's action, digitorum referring to the toes, and longus is a long muscle. Then we have tibialis posterior, which is going to be obviously in the back of the tibia. So anterior and posterior. Again, this is coming under here to support all of these tarsals here. If these muscles are weakened, then it's not going to help support the foot, and this arch is going to drop down and go flat. And if it goes flat, then each time you step, there's going to be more bowing and more pressure, and people can have plantar fasciitis because the fascia of the lower foot can get inflamed from irritation of that constant pulling, because it's not working like a spring like it should work. All right, now we have foot inversion. So I say if you drew an arrow straight down, if you shot an arrow straight down in your foot and the arrowhead's down here, if you're pointing the arrowhead in towards your body, it's inversion. If you're pointing the arrow away from the body, it's eversion. So in and then exiting. So, like I said before, because the tibialis anterior wraps around the medial side of the foot, as it contracts, it's going to pull this foot inwards. So pulling the lateral edge of the foot in towards your body. Then we have foot eversion. Again, the foot is exiting the body. So that lateral portion of the foot is going up and it's moving away from the body. And this is going to be fibularis or peroneus longus. This has two names. I personally like fibularis because it makes sense because it's along the fibula. But you may see peroneus on your imblex. Then we have the fibularis or peroneus brevis. So longus, long muscle, brevis, a brief muscle or short muscle. And again, this is wrapping around to the lateral edge, and when it pulls, it's going to pivot right here at the talus and kind of rock the boat to one side. All right. Now we're looking just at the toes, the flexion of your digits. So the ankle is stable. You see this is pretty stable here. And then you're just really focusing on curling your toes. So we have flexor digitorum brevis. So action flexion, location, your digits, and it's a brief muscle. Then we have abductor hallucis. So hallucis referring to the big toe. So it's going to abduct the foot at the big toe. Then we have abductor digiti minimi. So the small digit, the small pinky. Okay. And then down underneath, we have under the flexor digitorum brevis, we have flexor digitorum longus. And you can see how it comes a bit more farther out from the brevis. And again, if these muscles aren't working properly, then this foot goes flat. As we're walking barefoot, each individual toe, these muscles have to work independently to support all these toes. But if we're in a boot and a shoe all day long, then these muscles get weak and then that arch falls down. These lumbricals are holding the lumbar, if you will, together. So we can get a flat foot, and also that foot can widen if these muscles are not strengthened to keep the foot in line. And then again, we have the dorsal interossi, which are keeping those toes together and supporting this movement of toe flexion. All right. Coming back here, we have the flexors again, coming all the way up to support and stabilize on the fibula. Right. And then we have the flexor digitorum longus come here, stabilizing on the tibia and running under the foot all the way down to the toes. And lastly, we have digital extension. So you're lifting the toes up off of the ground. So of course, the name is going to be extensor for the action, hallucis for the location for the big toe, and the description is going to be longus. Okay, same thing for the digits, the toes. The extensor digitorum longus. Then we have brevis. And then we have extensor hallucis brevis for the big toe. So as you can see, the toe is independent from, the big toe is independent from the rest of the toe, the digits, because as we're walking barefoot, we have to independently use these toes to balance this uneven terrain. And then you have your lumbricals again supporting this movement and keeping these toes in line. And that is the lower leg and foot. It's pretty self-explanatory for each side. So this is much easier than the hip complex.